Welcome to Brilliant Quiz. Today we are going to solve some JEE exam problem from the chapter Laws of Motion. So the first question is, a massless spring gets elongated by amount x1 under a tension 5 Newton. Its elongation is x2 under the tension of 7 Newton. For the elongation of 5x1 minus 2x2, the tension in the spring will be. See, in the question they are telling that for 5 Newton the extension is x1 and the tension of for 7 Newton is there. It is x2 is the extension they are telling. Then they are telling about the elongation of 5x1 minus 2x2. The corresponding tension we have to find out. So here we know, here spring equation that is the force for a spring is F is equal to Kx, where F is the spring force, K is the spring constant, X is the extension, F is equal to Kx. By applying here, we see here 5 is equal to Kx1, spring constant into x1, 5 equal to Kx1. Then this next equation, we see 7 Newton. 7 Newton is equal to Kx2. x2 is the corresponding extension. 7 Newton is equal to Kx2. Then we have to find out the tension, the corresponding extension 5x1 minus 2x2. So F is, we are giving the equation F equal to Kx, that is F equal to K into 5x1 minus 2x2, because 5x1 minus 2x2 is the extension. So here by multiplying we get F is equal to 5kx1 minus 2kx2. So see, from above you can see that kx1 here, kx1 is equal to 5, so we are putting here 5, and here kx2 you can see in the upper side you see kx2 is equal to 7, so we are putting 7 here. So we get 5 into 5 minus 2 into 7. So the answer is 25 minus 14, which is equal to, we get 11 Newton. So the correct option is option 3, that is 11 Newton is the answer. Next question. See, the length of a light string is 1.4 meter when the tension on it is 5 Newton. If the tension increases to 7 Newton, the length of the string is 1.56 meter. The original length of the string is the question. So in the question it is given as the length is 1.5 meter when the tension is 5. 5 it is 1.4. Then when the tension increases to 7 Newton, the length of the string is 1.56. We have to find out the original length of the meter of the string in meter we have to find out. So here also first we are applying the equation F equal to Kx. So K is constant, X is extension. So we get F equal to Kx, X is equal to L minus L, that is L0. If you are taking L is initial length, L1 is the final length. So L1 minus L0 or L1 minus L is the extension. So in the equation if you are giving here 5 is equal to K into the first L1, you see L1 here is 1.4 minus L0. So we are giving the first equation, substituting the first equation. Now in the second one, if we increases the tension into 7 Newton, so we are giving 7 is equal to against K into, then the length is here it is 1.56 minus L0. So in the both this equation L0 is there. By using these two equations you have to find out the value of original length L0. So dividing this equation 1 and this equation 2, 1 by 2, we will get what? 1 divided by 2 we get. 5 by 7 is equal to 1. K get this K here get cancels. So 1.4 minus L0 by 1.56 minus L0. So by cross multiplying here this to here we get 5 into 1.56 minus L0 is equal to 7 into 1.4 minus L0. Just simplifying we get 5 into 1.56 minus 5 into L0 is equal to 7 into 1.4 into 7 L0. So 5 into 1.56 you get 7.8 minus 5 L0. Here 7 into 1.4 you get 9.8 minus 7 L0. Then you get here, see 7 L0, 7 L0 to here you get 7 L0 minus 5 L0 is equal to, then 7.82 here, so you get 9.8 minus 7.8, so you get 2 L0 equal to 2, so L0 equal to 1 meter is the answer. A body of mass m is suspended by two strings making angle theta 1 and theta 2 with the horizontal ceiling with tension T1 and T2 simultaneously. T1 and T2 are related by T1 equal to root 3 T2, the angle theta 1 and theta 2 are. Here we have to find out theta 1 and theta 2, and it is given that the tension T1 is equal to root 3 T2. So, and it is given the what is theta 1 is given angles, two angles, horizontal making with the horizontal ceiling, and T1 T2 two tensions. If we are drawing it, we can get here T1 is here T1 T2, and already told you in the question that is theta 1 and theta 2. So we are giving here theta 1, here theta 2. So what do we get? It is theta 1, this also theta 1, theta, this also theta 2. So resolving the forces tension into horizontal and vertical direction, we get T1 in this direction T1 cos theta 1, in the perpendicular direction T1 sin theta 1. Similarly, T2 here, T2 in the horizontal direction, T2 cos theta 2, and in the vertical direction, T2 cos theta, T2 sin theta 2. Okay, then here we know that mg in the downward direction. So, we can resolve the forces. We know that this is in equilibrium. So, the horizontal forces and the vertical forces are balanced. So, if we are balance the horizontal forces, that is T1 cos theta 1 equal to T2 cos theta 2. So, we get, and in the question it is given that T1 equal to root 3 T2, it is given. So, substituting here, we get root 3 T2, see here it is T1, for we are substituting root 3 T2. So, root 3 T2 cos theta 1 is equal to T2 cos theta 2. From here we get what is cos theta 1 by cos theta 2 is equal to theta 1 by theta 2 is equal to T2 by root 3 T2. So, T2 to get cancelled, we get 1 by root 3. See, in the option you can see theta 1 30 is there, 60 is there, 60 30 is there, 45 is there, 30 60 is there. So, by analyzing we get if we get theta 1 60 and theta 2 30, theta 1 60 and theta 2 30, theta 1 60 and theta 2 30, we get the answer 1 by root 3. So, the correct answer is option 2, that is theta 1 60 and theta 2 30. But here it is also given that T2 equal to mg by 2. We had to find out that also, that is from the vertical forces we have to balance, that is T1 sin theta 1 plus T2 sin theta 2 is equal to mg. If you solve that, you get the value that is T2 is equal to mg by 2 also. So, the correct option is here 2. Next question. A body of mass 1 kilogram is suspended with the help of two strings making angles as shown in figure. Magnitude of tension T1 and T2 respectively are in Newton. See in the question, the mass is given as 1 kilogram. Then the magnitude of tensions T1 and T2 we have to find out. From the figure, we can see T1, T2 is there, angle 60 is there and 30 is there, and weight mg is downwards. So, we have to find out T1 and T2. See, here also we have to resolve the forces T1. So, in this direction, T1 cos 30, here it is T1 sin, T1 cos 60 here, and this is T1 sin 60. And here also this is T2, T2 cos 30 is here, this is T2 sin 30. So, by equating the equations, we get T1 cos 60, this is T1 cos 60 is equal to T2 cos 30, this is T2 cos 30. So, we get T1, the value of cos 60 is equal to 1 by 2 we are putting here, and cos 30 is root 3 by 2 we are putting here. So T1 into 1 by 2 is equal to T2 into root 3 by 2. So it is equal to T1 is equal to root 3 T2 to T we are here 2 are we are cancelling, so T1 is equal to root 3 T2. Now we have it coming to T1 by T2 is equal to root 3. Then T1 sin 60 plus T2 sin 30. So in the vertical direction we are solving, that is T1, this is T1 sin 60, and here it is T2 sin 30. T1 sin 60 plus T2 sin 30 is equal to, the mass is equal to the weight here mg. So here sin 60, the value of sin 60 is root 3 by 2, and sin 30 we are putting is 1 by 2. So T1 into root 3 by 2 plus T2 into 1 by 2 is equal to 10 we are giving, and we are multiplying this 10 with 2, here we get is 20. So root 3 T1 plus T2 is equal to 20 we are getting. Now here, but we know that T1 is equal to root 3 T2. Here we get T1 is equal to root 3 T2 by putting here we get, so here root 3 into here T1, T1 is equal to root 3 T2, root 3 into root 3 T2 plus T2 is equal to 20. So we get root 3 into root 3 becomes 3 T2 plus T2 equal to 20. So 4 T2 is equal to 20. So T2 is equal to 5 we are getting. So then T1 we get, we know T1 is equal to here T1 equal to root 3 T2. So root 3 into 5, we get 5 root 3. So we get the answer is correct option is 2 is the correct option. That is T1 is equal to 5 root 3 and T2 is equal to 5 is the answer. Two masses M1 and M2 are tied together at the two ends of a light inextensible string that passes over a frictionless pulley. When the mass M2 is twice that of M1, the acceleration is A1. When the mass M2 is thrice that of M1, the acceleration system is A2. We have to find out the ratio A1 by A2. So here given two cases. The first case is M2 is twice that of M1, first case. Second case is when the mass M2 is thrice that of M1. So A1 by A2 we have to find out. So here we know the equation for acceleration is equal to total force by total mass. Total force by total mass. So see, the total force means first here it is 2, mass is 2m. So here 2m and m. So here 2mg and mg. So the net force is 2mg minus mg divided by total mass. Total mass is 2m plus m, which is equal to 3m. So we get mg by 3m. So we get the answer. Then A1 is equal to, you get g by 3. Now in the second case we can see A2 is equal to, the second case thrice that of M2 is thrice that of M1. So this is equal to 3mg, 3m. Here it is 3m and here is m. So the net force is 3mg minus mg. Total mass is 3m plus 4m, which is equal to 3m plus m, which is equal to 4m. So we get 3mg minus mg divided by 4m is equal to 2mg by 4m. M get cancelled and we get g by 2. A2 is equal to g by 2. So from here we get A1 equal to g by 3, A2 equal to g by 2. We have to find out in the question A1 by A2. So A1 by A2 is equal to the g by 3 divided by g by 2, which is equal to g get cancels, we get 2 by 3 is the answer. So we can see the correct option is B, that is 2 by 3 is the answer. A spring balance is attached to the ceiling of a lift. A man hangs his bag on the spring and the spring reads 49 Newton. When the lift is stationary, if the lift moves downwards with an acceleration of 5 meters per second square, the reading of the spring balance will be, is the question. So here you can see 49 Newton is given, is force. the reading, so that is force. Then what the lift, first this lift is stationary, so it is 49 Newton. Then lift moves downwards with an acceleration is given 5. So the downward acceleration is 5 is given. At that time the spring balance will be the reading we have to find out. See, for this we have to find out the apparent weight. The apparent, if the lift is going downwards, the equation for apparent weight W dash is equal to mg minus ma. See here, mg is given as 49, mg is given, a is given as 5 meter per second square. Then the value of m is, mg is equal to 49, so m is equal to 49 by g, so 49 by 9.8, we get 5 kilogram. Then W dash is equal to, in the above equation, mg, that is 49 we are adding, minus m is 5 and a is 5, so 5 into 5, 49 minus 25 you get, so 49 minus 25 is equal to 24 Newton. So we get the correct option is A, 24 Newton. Option is A. Next question. Three forces start acting simultaneously on a particle moving with velocity v. These forces are represented in magnitude and direction by the three sides of a triangle ABC. The particle will now move with velocity. See, in the question you can see three forces acting simultaneously on a particle moving with velocity v. These forces are represented here. See the first force, you can see this is the first force, and this is the second force, and this is the third force. See, from the triangular law of vector addition, the resultant of these two forces is this one. So the resultant of the first two forces is in this opposite direction of the vector given here. So these two are in opposite direction. So the net force here, net force is equal to 0. So net force is equal to 0 means no force is affecting in the motion. So the velocity remains unchanged. So the correct option is D. Vector v, velocity vector remains unchanged. Next question. A disc with a flat small bottom beaker placed on it at a distance r from its center is revolving about an axis passing through the center and perpendicular to its plane with an angular velocity omega. The coefficient of static friction of the disc is mu. The beaker will revolve with disc if the question. See, in the question it is given as beaker, the radius is given r, distance is r, so it's rotating with r, revolving about an axis passing center. Then the angular velocity is given, that is omega. The coefficient of static friction is disc is given is mu. Then we have to find out the relation. See, here you can see here it is a circular motion. The beaker undergoes circular, the disc and the beaker undergoes a circular motion. In every circular motion there should be a centripetal force. Here the centripetal force is provided by the frictional force. So we can say the centripetal force should be less than or equal to friction force. Here the centripetal force should be less than or equal to friction force. So the equation for centripetal force is mv square by r or mr omega square, where m is the mass, r is the radius, omega is the angular velocity. And the equation for friction force is mu n. Mu is the coefficient of friction, n is the normal reaction. Now we know the equation for normal reaction is n is equal to mg, mass into gravity, mg. Now putting n equal to mg here, we get mr omega square less than or equal to mu mg. From this we have cancel m and m, we have to cancel. So we get r omega square less than or is equal to mu g. So from this r is equal to mu g by omega square. We get r less than or equal to mu g by omega square. So here the correct option is B, that is R less than or equal to mu g by omega square. Thank you.